we have observed your HDFS and MapReduce. So I need not specifically mention any time Hadoop means HDFS and MapReduce. The moment I use the word Hadoop, I implicitly mean HDFS and MapReduce. It also has got a standard structure called master-slave architecture, or it follows that. And I need not tell you again, in the master-slave architecture, there will be exactly one master and there could be n number of slaves. Even when you come to your HDFS, I mean in terms of storage, it follows the same master-slave architecture. Even when you go to your MapReduce, there also it follows the same master-slave architecture. So in any typical Hadoop cluster, there will be a minimum of 5 daemons. I mean a background process. A daemon is just nothing but a process running in the background. You will not be able to see that with the naked eye, but its presence can be observed or it can be felt. Such type of thing is what we call it to be a daemon. 5 daemons. We have 5 daemons. They are called name node, then we have data node, a backup to the name node called secondary name node, backup to the name node called secondary name node. Then we have job tracker. Then we have task tracker. These are the 5 daemons we have, out of which name node, secondary name node, and job tracker, all these we call it to be the masters. So there exists only one. There will be exactly one name node per cluster, one secondary name node, and one job tracker per cluster. And these are slaves. Whatever you are seeing here, these are slaves. These could exist any number. These could exist any number. Any number. In terms of your cluster. And masters exist. The very word itself is telling you there will be only one master and could be number of slaves. Usually, on a node inside the cluster, both the data node and the task tracker are going to coexist. This is a high-level architecture of your Hadoop. HDFS layer where we have a name node and could be any number of data nodes. Of course, secondary name node is not shown here, but secondary name node is going to work as a backup name node to your name node. Because name node is the one who knows the entire file system. The entire cluster file system is maintained, which file, where it is stored, into how many blocks the file is actually been divided, where those blocks are present. All those details will be captured by the name node. Don't worry, we are going to talk very in detail about each daemon at the later stage. But before that, I would like to know clearly from your end whether this master-slave architecture is clear to you or not. What we mean by that. Rishi.
Yeah, Srinivas, so node here means a machine. I mean, basically it's the CPU or?
Absolutely, you are absolutely right. Node here means a machine, a physical machine which is in the cluster.
Okay.
So you'll be having nodes like this. There will not be any difference in terms of when you form a cluster, usually how it is going to be. Let me also show you that if at all it is available here. Let me show you. Yes. This is how your Hadoop cluster is going to be. You might have seen here very clearly Hadoop cluster where this entire, whatever the vertical box you are seeing here is one rack. Usually it will have 24 machines connected. Depending on the switch capacity, if it is a 24 port switch, I think 23 will be there because one port I need to use it for my uplinking. So 23 nodes, 23 physical machines can be in this rack. Usually at the data center level, you will not be seeing tower boxes. Tower boxes will not be seeing. We'll be seeing this kind of flat, I don't know whether you have that understanding or not, a rack server, if you see. So this is what the rack server is. This is going to be like this. I think you are noticing here. So this will go and sit in that rack. That is why we call this as a rack server. What your tower kind of server will have, everything this also will have. Hard drives, where hot pluggable drives will be there. You can, if some hard drive is spoiled or something went wrong with that, I can and swap those hard drives. I mean, not every rack server, but the recent ones what you are seeing in the industry. This is how the rack is going to be actually. Whatever you are seeing here, the image. Why this is so slow? You see the rack here. This is the rack. Are you able to see this one, Rishi?
Yeah, I can see that. So these all these machines which are lying there horizontally, are they? Is one of them is all the part of the name node, for example?
Yeah. Now let us come back to this one. One node, I mean one server is the name node exclusively.
Okay. Okay.
And
So server
one
means
server, yeah,
not the whole rack, just one machine out of in the rack.
exactly. Whatever you are seeing here, small dn plus tt, dn plus tt, that is data node plus task tracker. Usually, data node and task tracker are going to reside on the same node. Data node and task tracker. Data node, task
Okay.
tracker. They will be on the same node, and name node will be on a separate node. Usually, name node will be on a high-end machine. So usually, masters will be on masters. Usually will be on high-end machines.
Mm-hmm.
High-end machines, because they need to do a lot of or they need to render a lot of service. Say for example, you take name node. Name node is going to capture every minute details of the file system. File system, I mean only metadata. It will not store the actual data. It only stores the metadata. I mean, what is a file? What is a file? And how many blocks? That is like, file name, and how many blocks, and where those blocks are being stored. All those details will be stored as part of your name node file system. So if you want to know, or if you want to process a particular file, only name node knows where that file and how many blocks and where those blocks and where the replicas of those blocks, all those will be known only to the name node. So name node is what we call it to be the entry point into my cluster. For any reason, if name node is down, for any reason, then the entire cluster becomes inaccessible. We will not be able to access the cluster at all, because name node is the one which knows everything. Here. I mean everything in the sense file system. Even if I want to do my processing, though the actual processing is going to be done by the job tracker with the help of task trackers, but even the job tracker needs to know where the blocks are present, which blocks need to be processed. That is going to be shared by the name node only. So processing is going to be done by job tracker, but which blocks needs to be processed and all needs to be shared by name node only. So that is the reason why name node is sometimes called as SPOF, S-P-O-F, which means single point of failure. Single point of failure. If this is failed, single point of failure. If this is failed, your entire cluster is going to fail. Why the entire cluster is going to fail? Because job tracker may be running, but job tracker needs to know which file needs to be processed, where the blocks of those, of that particular file are present. All those things known only to the name node. If name node is not accessible, then your entire cluster becomes inaccessible. For any reason, if the name node got corrupted, I mean, imagine it got burned, or the hard drive got corrupted. Something went extremely wrong with the name node. The entire cluster will become useless. So that is definitely a threat. That is the reason why for the name node only for the name node, not to the other nodes. So don't get confused with the node and the actual node in the cluster. Of course, there exists the relation, but this is called a physical node, and these are the process running, and the names also been given in the same way, so that there will not be much confusion. But if this is confusing you initially, you need to bear for a few sessions so that you get adjusted with the terminology. So that is the reason why name node has got a backup called secondary name node. Backup doesn't mean when the name node is down, automatically secondary name node will come into picture. No. Secondary name node will work only as a backup name node. In the event of name node failure, the admin needs to recover the data from the secondary name node and construct your name node back and make your name node up and running, then only your cluster becomes accessible. It is not that when the name node is down, automatically the secondary name node will be up and running. Secondary name node will not automatically come and start rendering its service. It is always a secondary. The thing is, when the name node fails, if it is not related to your hardware, something like that, then you can identify what is the problem and try to start it again. If there is some critical problem where the data is being lost on the name node in terms of the file system, then we can take the backup from the secondary name node, construct your name node. Of course, this is all the responsibility of the administrator. So take the backup from the name node, secondary name node, construct the name node and start this one, and then when it is up and running, your cluster again becomes accessible. So that is all about name node, secondary name node and data node. Data node is actually the workhorse. Why we call that as a workhorse? Usually the slave nodes, whatever I am saying here, they contain both your data node and a task tracker. That is the reason why there in the diagram I have shown both the task tracker and data node, DN and the TT. I have shown that in the diagram here, you can see. Please watch this diagram closely, friends. You won't let me make it more big. Yes. Watch this diagram for a minute and try to digest this one. See, 24 racks. See, inside your rack 23, depending on the switch capacity, 23 nodes and one for the uplink, so 24 port switch. 23 machines can be there, what I have shown you here in the rack here, right? Connected to the switch, that is called uplink switch, whatever I am showing you here. So such 23 racks to one switch, okay, and again such racks, number of racks, up switches, they can have one more layer on the top, depending on the number of in the data center. If you go and see, you will be having thousands of, it's called a server farm. It's called a server farm. You'll be having thousands of servers. How? The architecture is like this. That is why in between I kept dots to make you to understand that these kind of racks can be in any number. That is what I technically call it as linear scalability. You notice this entire diagram. Name node, there is only one. Job tracker, there is only one. Secondary name node, there is only one. Data node and a task tracker together on one machine. Like that, we can have any number. That is what I am technically calling it as linear scalability. So this is rack N. You can have, depending on your need increases, your storage need increases, then you can add more and more. As of now, like this, with Yahoo has got the highest Hadoop cluster on this planet as of today. 13,000 odd nodes live running with Yahoo. 13,000 odd. The figure is not exact, but that's growing. Hope you understand what I'm trying to share with you here.
So, Srinivas, data node and a tracker are normally of one machine, as you have shown here. Though they're slaves, they're multiple, but are they a part of one CPU or they're separate CPUs? Data node and tracker, TT.
No, come out again with your question.
So data node plus the TT, the tracker thing which you have set, they are all a one machine?
No. They're all on different machines. DN plus TT, DN plus TT, what you're seeing, they're all on independent machines. That is where I've shown you here. So whatever you are
Okay.
seeing here, all these are the servers, each one. I think you see.
Yeah, so tracker is a separate machine, data node is a separate machine. So they
No,
just put them as cluster.
no. They're both put together on one machine.
Oh, that's what I was asking. Okay.
Yeah. Usually, why data node and task tracker are going to be on the same machine? They're going to be on the same machine. There is a concept called data locality. I mean, as I explained you just before, data node is the one which actually stores the data. Data node is the one which actually stores the data in the form of blocks. I explained you in the last discussion that your entire storage is divided into uniform blocks of size ranging between 32 MB to 1024 MB. I mean 1 GB block size. 1 GB block size. So that is all going to be decided by the Hadoop admin while forming the cluster, setting the block size at the cluster level. So the size of the block is being decided at the cluster level. Your entire storage is being uniformly divided to the blocks of that size. Now all these are the blocks of data on your data node. Now data is being stored here. Now when it comes to the processing, suppose if this data from this data node and one more data node and one more data node, what I'm showing you here. Imagine now few blocks from here, few blocks from here, few blocks from here, put together one file. Let me draw with a different color. This one, this one, this one, and here, yes. These colored blocks belongs to one file. Okay, these are all belongs to one file. Or technically I call that as data set. This data set has got how many blocks? Imagine 5 blocks. Now tell me if these 5 blocks needs to be processed, because my intention is to process this file, which means I need to process these 5 blocks. Now, is it a good choice or option to me to bring all these 5 blocks to one place? I mean onto a different machine, bring all the 5 blocks and process here. Is it a good choice?
Yeah, looks like, yeah.
But thing is, in this case it is okay. But imagine if I need to process a data set of 20 TB. Is possible, quite possible. If I need to process a data set of 20 TB, how it is possible for me to gather the 20 TB data to one place? I cannot bring it to one place. It is not possible to bring practically. So what I do is, in that case, instead of me pulling the data to one place, I send my code there only. I send my code to the place where the data is present. So there are two models basically, or the two models what we have: pull the data and push the code. In the traditional processing methodology or mechanism, pull the data is best. Say for example, this is your browser, and from browser you send a request to the web server, and web server in the background is going to interact with the database. Now I send the username and the password. The web server is going to interact with the database. For this given user, what is the password it will bring? Your password, both been verified. If okay, I give one page. If not okay, I give some other page. In that case, in that situation, I think there is an echo. In that situation, pulling the data from the database to the place where web server is running is absolutely fine. Pulling the data from the place where web server is running is quite easy, because I only need to fetch small amount of data and I bring it here into the web server. I process it here. The password from database and the password given by the user both been compared. Everything is fine. Then I render one page. Otherwise, I render some other page. So in that case, pull the data is absolutely fine. But in the case of big data, what I am showing you now, you think it is possible to pull the data to one place and then start processing it? It's definitely not possible. You agree with me, Rishi?
Yeah. Mm-hmm.
So in that case, what I do, I push the code to the place where data is there. That concept is called data locality. I mean, where data is present, there only the processing is going to happen. But if you observe closely, when I am processing these three blocks here, it is not complete processing. I get only partial output from these three blocks. When I process this block, I get some partial output. I process this block, I get some partial output. Now all these partial outputs needs to be further drilled down. That is the reason why this programming model is divided into two phases minimum. Map is one phase and reduce is one more phase. That is the reason why we call this as map reduce model. I mean the processing model. It is not a single phase model. It is a multi-phased processing model where minimum you have map and reduce phases in terms of processing any data. Rishi, you can keep yourself on mute. Whenever you
Okay,
want,
sure.
you can unmute yourself. Yeah, thank you. Because there is an echo coming from the back. So this is all about your cluster and the roles and the basic inputs of your the daemons what you have. You have name node, and then the backup to the name node called secondary name node. The backup to the name node called secondary name node, and we have data node. These three are called HDFS daemons. HDFS daemons. Then you have job tracker, and then we have something called task tracker. And these are called map reduce daemons. Hope you got the 5 daemons you have here. These are the 5 minimum daemons. That is the reason why I asked you to go through this architecture so that you will have understanding, but that's fine. You can see that here name node, where it only stores the metadata, data nodes, which actually stores your data. This is all maybe a part of one rack, and these part of one more rack. So name node and data node are pieces of software designed to run on commodity machines. If you might have gone through this documentation, you might have came across this term called commodity machines. That is what the beauty part of your Hadoop. You come across the term called commodity machines. What we mean by commodity machine? What we mean by commodity machine? One second, friends. One second. Commodity machines are just nothing but the normal hardware. Normal hardware doesn't mean your assembled hardware. I mean, at least I'm talking at the data center level. Normal hardware, I mean, not your enterprise class. Usually, for the sake of your data storage, databases, they're being set up on enterprise class data servers, which are very expensive. These are very expensive. Usually, I set up my databases on the high-end servers, which are very expensive. Very expensive. We don't need that level of hardware to set up your cluster as part. Plain, regular, normal hardware, of course, they are branded. Dell or Cisco, UCS or HP, of these make only, but they need not be enterprise class data servers. I mean, they can be normal commodity. Regular servers are okay to store your data. So that way, of course, if you are really interested to set up a cluster with your assembled hardware, which is procured from the local market, that is also fine, because your cluster has got the mechanism. At every level, we have fault tolerance. At every level, storage level, we have fault tolerance, and processing level also we have fault tolerance. So we need not worry, even if you are going with a very low grade local assembled boxes. With that also you can set up the cluster. But the problem is the rate of failure when you run these things 24/7, 365 days, then this hardware may not be able to sustain because of improper ventilation or improper cooling solutions. So these will get off frequently. That is the reason why we don't go with locally procured assembled hardware to set up your Hadoop cluster. We usually go with the branded, but they are commodity. They're not, I mean, the servers which are for regular normal usage, those kind of branded servers we'll be using, which has got proper cooling solutions and the robustness in terms of running it 24/7. But we don't require enterprise class data servers, which are very expensive in terms of storing your data. You got my point, friends?
Dinesh, one quick thing.
Yeah.
You mentioned something saying a name node and a secondary node, and the secondary node is used in case the name node goes bad. So basically, we retrieve the data or retrieve the components from secondary node and then put them back and get started again on the name node. So does it mean that name node and secondary node have to be in sync always? Because name node is the primary guy working, and secondary node is already kept in sync when they are live. Both of them are all in sync.
Very classical, this thing. I really appreciate your micro observation. Obviously, both your name node and secondary name node should be in sync all the times. That is an automated process which need not be done manually. That is purely an automated process. Name node and secondary name node, having the same data being maintained on the secondary name node, all the automated process. We need not do that anything. We did not do anything in that regard.
Okay. Okay. Yeah. Thanks.
When the cluster is
Otherwise,
set up, that time itself, all these been taken care, so we need not worry for that.
okay. Cool. Thank you.
So we have now all these I think you got the basic understanding of all the 5 domains what we have here. I mean, your name node, secondary name node, data node, job tracker and task tracker. Why? This is one thing that I would like you to clearly understand at this stage. Data node and task tracker, why they need to exist on the same node. This I want you to understand clearly. Especially when it comes to big data, why both of these needs to be on the same. Because of the data locality concept, which I explained you just before, because of data locality concept. You got this point, friends? Sunil, Murthy, John.
Yes. Yeah. Yes, Srinivas. Yeah, we
Yes,
got
yes,
it.
Srini.
So if you
Yes,
are
Srinivas.
clear,
Yes.
yeah. So I want you to be clear on certain basics before we move further. Why I want you to be clear on certain basics is for the reason. Without those basics, understanding the concepts will become very tough for us in the coming days. And please watch this diagram closely, which gives you a lot of information.
Srinivas, actually, when you were explaining the data locality thing,
Yeah.
that, yeah, I mean, can you go back? Is there that slide is still there or that is gone? That data
Yeah.
Yeah, so I was with you. So basically, you were explaining that why, if it is easy to, if all these data nodes are spread across, it is easy that if they're all in the one machine. But then you express that if you have a lot of data nodes like 20 terabytes or something, then it's not possible. So I think I lost you somewhere. Where you so what? How, so that means data node and tracker, if they're the same level, then it would be easy for processing. That's why it, that's the concept that we want them on the same machine.
Yeah, that is where I mentioned here. We have two things, right? One is pull the data. So pull the data
Yeah.
concept is ruled out in this case for the reason we cannot bring all the big data to one place and process it. As we cannot do that one, that is the reason why we are going for a cluster. Why we are splitting the
Yeah.
data and storing it on multiple machines. So
Yeah.
in the big data case, it is always a good idea that you push the code to the place where data is. You push the code to the place where data is available. So where data is available, there only the processing is happening. So as a result, what happens, if you see closely, usually when you develop a MapReduce job,
Yeah.
it is going to be in the range of 2 MB or 3 MB, not more than that. Your MapReduce job will not be more than this size. So pushing this 2 MB or 3 MB file to the nodes where my data is available is not a problem.
Mm-hmm. Okay.
So my what happens? My code will go to this place. Say for example, I have a 100 node cluster, but my required data is present on 8 nodes in the form of blocks, like 100 blocks I have assumed. These
Mm.
100 blocks are present on 8 nodes. So to how many nodes I need to push my code? Only to the 8 nodes, not 100 nodes.
Yeah.
So I push my code to 8 nodes where my data is present. Of course, my entire cluster is 100 node cluster. So I push
Mm.
my code to the place where data is present, so that
Mm.
pushing this 2 MB file to all the 8 nodes is very, very easy in terms of network, in terms of IO, and in terms of the speed, right?
Mm-hmm.
So
Yeah.
when the code goes and sits on these nodes, what it do? It process the data locally itself, right?
Yeah.
So data movement. See, the biggest challenge all the times in any processing is pushing or making the data travel across the network and go to some place. Then you process data. It is expensive. I mean, compared. See, within the machine also it is expensive, because if the data is present on the secondary storage, bringing that into RAM and process it is going to be a challenge again. That is also going to be time consuming. Apart from that, if the data needs to be transported across the network and needs to process on some machine, it is going to be much more expensive. See, in any processing ability, the most challenging thing is I/O. That I/O could be network I/O, that could be disk, anything. But I/O is the most expensive activity. The reason behind it is, see, the rate at which the processor is going to process the data, the processor is going to process, I mean, it's only a rough figure to make you to understand. 1 million bytes, 1 million bytes per second, assume. I mean, don't look at these numbers. Try to understand the concept. The processor is capable of processing 1 million bytes per second. But at the same speed, if I try to read the data from the hard drive by moving its read-write arm, because of that speed, it leads to the friction, and that may lead to sparks, and that may eventually go to the level of getting your hardware burned. You cannot move the mechanical parts beyond some speed. If you do that, that produces heat. You noticed when your laptop is running, after 1 hour or 2 hours, you see the heat coming out.
Yeah.
Or when some intensive processing is happening, when your processor, usually you go and see, usually your processing, you go and see your this thing, CPU will be usually, now we have a lot of things going on, meeting is going on, my applications, voice data is going and all these things. But still, you see, 19-20% of CPU only is occupied. But imagine if this CPU is 95, 98, 99%, 95, 98, 99%, the amount of heat you see from that machine. That is the reason why cooling solutions are most important in the machines where intensive processing, intensive activity goes. Notice, friends, sometimes when your machine is occupied, observe your CPU at 70 plus, 70% above utilization. The amount of heat that comes out of your laptop is different. And even the disk what you are seeing here is only 2%, 3%. Network is almost zero. I think you are seeing here. So the same when it comes to your activity, the level of, the rate at which the processor is processing your data, at the same rate, I may not be able to provide the data to it. That is why most of the times I take the help of buffers. So I put the data in the buffer. From buffer, I give it to the processor. Keep filling this buffer so that at least I can improve the efficiency. But when it comes to your disk reading or network transfer and all, it has got its own limitation. Of course, time to time, this is getting upgraded. That is why you might have seen pen drives which are capable of reading and writing fast with the help of your USB 3.0. That is why you might have noticed when you are going to see the pen drive USB that is 3.0 capability. I mean, the data transfer rate is going to be more in terms of these thumb drives. But at the same time, your laptop also should have USB 3.0 slots. You're not able to connect. You can connect and do it, but its maximum benefit cannot be achieved by you. So it is you who need to understand here the rate at which the processor is capable of processing your data. At the same rate, we will not be able to read the data from the disk or push the data across the network. So it has got its own limitation, which you need to understand that, friends. Make sense?
Srini, I have a question.
Yeah, please, please.
So you are saying we are going to push the code to these nodes, right? So how we are going to do that? Is it a manual process or like what is that we are going to do?
Yeah. So how we do is when we submit the job, of course it is too early to discuss that, but to make you to understand the concept at least at this stage, when you are submitting the job from the command line like this, Hadoop zar, I specify my jobs.zar, and in that you want to run my job, and the input data is abc.txt, and the output needs to be stored in abc underscore out. This is how I submit the job. The moment I submit the job, who is going to receive this job is your job tracker is going to receive the job. Your job tracker receives the job from the client. This is a client, and from the client, the job tracker is going to receive the job. Now, immediately, when the job is being received, the job tracker also looks into your input path. What is that input path? What you are given here, abc.txt. That is the input path. I think you are seeing abc.txt. This is the file, or this is the data which I want to process. Sometimes what I can do is I can say here at the root level a TMP, and in that you have something called sandbox, my data. I can give the directory also. When I give the directory, all the data sets inside the directory are being considered for processing. Okay. So that is an indication to my name node, indication to my job tracker. Oh, I need to process all the data sets present in that path. Okay. I get the input path. Immediately what the job tracker will do is it communicates with the name node saying, this is the input path. Tell me where the data, I mean the blocks for the given path are located. You got the point, friends? The job tracker is going to request the name node asking, please tell me for the given input path where the blocks are present. The name node is going to accept that request and send the response saying, for your given input path, there are 50 blocks, and those blocks are present on node 1, node 5, node 9, node 10, and node 11. Is what the answer your name node is going to give. Then immediately what the job tracker will do is, same zar file, .zar file, what it received, it sends the zar file to node 1, node 5, node 9, node 10, and node 11. Who is there on these nodes? You have a task tracker present. The task tracker is going to receive that zar file. I hope you are following with me what I am sharing here.
Yeah. Yes.
So
So you are saying node 1, node 5 is like those are all data nodes, right?
exactly. Those are all slaves. See, when I'm talking about job tracker, that there is only one master present. Rest of all, anything I talk in terms of processing, they're all slaves. Slaves, I mean task trackers. In the context of name node, there will be only one name node. If I talk anything other than that, they're all called slaves, nothing but data nodes. Okay. So my slave called task tracker is going to receive that. Which one? That zar file. and run that jar file against the data, present in that specific node. I hope you are getting the point.
Yes.
So this is all about your job tracker processing your data. So let me take you to the slide where see this here. You understand? You're looking at this diagram. I think it is pretty clear now.
Yes.
So the client submits the job to the job tracker. Job tracker is going to send that ZAR file. I mean, ZAR file nothing but the code. See, you are going to ship the code to the job tracker in the form of a ZAR file, nothing but Java archive. A compressed file specific to Java. That is called ZAR file. I will talk about that one when we come to MapReduce. But as we need to understand the concept by large, we are trying to see all these things at this stage. So what the job tracker immediately do? The job tracker itself cannot decide, send this code to these nodes. It cannot decide. Who need to tell that? Your name node should tell that, because name node has got the information about where the data is present. So it contacts the name node. Name node is going to reply saying, oh, for your input, these are the files present, and for these files, these are the blocks, and those blocks are present on these nodes. That response is given to the job tracker. What job tracker will do? Oh, in order to process this data set, the required blocks are present on these nodes. Let me send my ZAR file to all these nodes so that the processing is going to happen locally there. Now tell me, instead of you shuffling or bringing 512 MB blocks of 100 in number to one place, it is good that you push a 2 MB file to all the 10 nodes where your data is present, right? Which is easier? Either pulling 100 blocks of each 512 MB to one place, or pushing the code of 2 MB to 10 data nodes, which is easier?
Pushing the code.
Now, in this case, it is pushing the code. It is not that push the code is the best choice every time. It is not the best choice every time. So for the big data context, pull the data is going to be expensive because your data is in terabytes, and that data needs to be processed, and you need to bring the data to one common place. That is going to be an expensive thing. But when it comes to big data, as pushing the code is more easier and more effective, we are doing that. I hope you got the understanding what I'm sharing. Now, the most important aspect is the data replication. Data replication, first you need to understand. I want to store a data set of size. Look at this one very closely, friends. I want to store the data which is of 1 TB. And you know very well, 1 TB is nothing but 1024 GB. If my block size is 128 MB, is how many I get? For 1 GB, how many blocks I get? 8, I think. Yes, 8 blocks per GB. So for 1 TB, how many blocks I get? 1024 into 8. That is equivalent to, you agree with my point, friends? 8192 blocks to store my 1 TB data. Now these 8192 blocks are spread across the nodes on my cluster. Please follow this use case, friends. We deal everything in terms of use cases only. What is the use case now to me? I want to store 1 TB data set. 1 TB data set or data. When I use the term called data set, I mean by file. Data, I mean just data that could be one file or more files. So my intention of saying data set and data, it could be one file or more files. That is what my intention of saying that. Which requires 8192 blocks. So what I do, the data is being spread across now. You may ask me one thing, Srinivas, why we are doing like this? Because on a particular node, data node, it might have been filled because of storing some other data before. So I don't have enough blocks. That is why only 3 blocks are stored on my first node and 3 on the second, 5 on the third, 6 on the fourth, like that. So my 8192 blocks are being spread across the nodes like this. Imagine that my cluster of 200 nodes, one node going down is not an abnormal thing. One node going down is not an abnormal thing for whatever the reason. Could be your cable got cut, the uplink switch, the uplink connection has broken, or hard disk got corrupted, SMPS got failed, processor got failed, some component of the motherboard got failed. Whatever the reason it is, one node is down. Imagine this node is down and I want to process this data set. Can I do that or I need to wait?
I think we need to wait because partial data will not be coming from that node where it is down, right?
Oh, I'm really happy. I'm happy because in IT we either has got 0% or 100%. There is no such thing that exists in IT in between. There is no such thing exists in IT anytime, either 0% or 100%. No such thing called 99.99. This also is not considered. I mean, in the context what I am talking, either no data is available to you, happy, or every bit of data should be available to me. Not like that. Out of 8192 blocks, only 2 are missing. No problem. Let me continue my processing. That never can happen. Now, every offer and then one node is down, then your cluster available time is definitely less. You agree with my point? I fix that node, bring back that one, If the
Yes.
data is being pushed onto that, then it is going to be. That is the reason why we have a concept called replication. There is a new concept brought into picture called replication. What do you mean by that? Same data is being replicated on the other nodes in such a way, even if one node is down, still the data is being made available. You may ask me one thing, Srinivas, that is going to be an expensive process. How we are going to do that? That is what the beauty part of Hadoop. We need not worry. That is all the implicit internal mechanism of your Hadoop. That is nothing but your HDFS name node. That is the reason why name node is need to be set up on a high-end machine because it do a lot of things. It will not physically store any of the data. It only stores the metadata, but still it needs to do a lot of things. I'll show you here this slide, then you'll be able to understand what I mean by replication. Have a look at this one, friends. Look at this diagram very closely. There is a file by name foo which has got blocks 1, 2, 4. There is a file by name bar blocks 3, 5. If I want to process the file called foo, I need 1, 2, 4. If 1, 2, 4 are present, I'm happy to process my foo. If 3, 5 are present, I'm happy to process my bar. Now see here, if the replication factor is set to be 2, if my replication factor is set to be 2, then in that case you see here what is happening. You see that here. You please close one node with your fingers on the screen, friends, and tell me whether 1, 2, 4 is available or not. Any node you close, with your fingers. Say first node you close with the fingers, check whether 1, 2, 4 available or not on whatever the node. Put your fingers against the middle node and check whether 1, 2, 4 available or not. Put your fingers against the third one and check whether 1, 2, 4 available or not. Same like 3, 5 also.
Yes.
This kind of distribution is going to be taken care by the name node. We need not worry and we need not take the headache. See how beautiful it is, you just see. That to be for the replication factor 2. To make you to understand clearly, I have taken up this one. But usually on the Hadoop cluster, the replication factor is being maintained 3. The default replication factor on the cluster is 3. Okay. You may ask me one thing, Srinivas, if that is the case, then a lot of space is getting wasted. Of course. Now the per byte cost in terms of today's is not that bothering factor to me because the storage has gone down. The storage capacities are getting increased. We are getting 1 TB, 2 TB, 4 TB drives at a very cheaper cost. So per byte cost is very less to me. No problem, even if the data is being replicated. At the cost of my availability, my replication is bearable. At the cost of my data availability, my replication is bearable. It's a sweet pain, no problem. I hope you are getting the point. What I mean by replication. And because of this replication, I can achieve a fault tolerance. Even in the case of fault, we are able to tolerate that because data is still being made available. So depending on the requirement, the administrator can decide to choose a replication factor either 3 or 4 or even beyond. Usually we maintain it at 3. If required, this can be always configured based on the need. I hope you got the point, friends, what I'm trying to share with you here. And all this information is present in some form here. What is data replication? What you are seeing here, the diagram. That is the reason why I'm asking you to go through this theoretical stuff. Most of this one is been been handled in the class, But still you go through this theoretical data, you get confidence. Oh, tomorrow when you start facing the interviews, then you understand any point been missed in the session, which can be, because it is not possible to cover every point across your Hadoop ecosystem, which we are going to discuss. That practical limitation, I think every one of you understand and agree. That is the reason why I'm showing you the path. I know very well, friends, when you start going through this theoretical stuff, you get a lot of questions. And again, it is a pain to me to make you to get those questions cleared. But I don't mind, even if it is painful to me. I want to take that. That is the reason why I'm showing you the path, the original path from where you can get the documentation. And if you go through the documentation, your journey will be very smooth. And the biggest advantage is in the coming days, if there is any new release from that particular product or some changes, you need not rush to someone to upgrade your knowledge. You just go through the document yourself. I know very well that this is going to, this is going to kill this training business in the longer run. But I appreciate, friends, if you can be on an auto mode, that even in coming days, new components are being released, how you can mature your skill set. Because every time it may not be possible to come to the sessions. More than commercial, I want all my participants to be in that autonomous mode. That is possible only when you go through this kind of technical documentation, which I'm showing you and asking you to go through it, encouraging you to go through it. I know it will be more load on me if you start going through this one. A lot of questions need to be answered, but I'm ready to take that pain. Please go through this one, friends. Then only the term called hardware failure. Hardware failure is a norm rather than exception. A HDFS instance may consist of hundreds or thousands of server machines, each storing a part of the file system data. The fact that there are a huge number of components, that each component has a non-trivial probability of failure, means that some component of HDFS is always non-functional. Therefore, detection of faults and quick automatic recovery from them is a core architectural goal of HDFS. Whatever I explained you till now is that one only. Your data replication, why we need data replication? All that you come to know only because of this. Large data sets. Applications that run on HDFS have large data sets, nothing but files. Yeah. HDFS is tuned to support large files. Here they are using the term called large data sets. Here they are using the term called large files. Both are the same. Contextually we change. So I advise you to go through this technical documentation, friends, so that it's going to be easy for me to handle. Now my next point in the same line is, here if node is failed, that is fine. Node is failed, we have the fault tolerance. But imagine, friends, for some reason, don't ask me how many times that kind of situation may arise. May arise frequently or may not arise at all. But imagine if a complete rack is down, then what you are going to do? That is the reason why I came back to the same diagram. If one node is down, with replication we are able to manage that. But if the entire rack is down, because the uplink got broken, something went wrong, or the port in the switch, then this will lose the communication with the rest of the nodes inside the cluster. Now, in that case, what do you do, friends? If the entire rack is down. You got my point, friends, what I'm sharing here?
What kind of rack? What kind of rack? Happening at the node level, and when they all are replicated, I mean, if they all are already replicated, then automatically the rack gets replicated, right? Or only the data nodes are replicated. So what I'm trying to say is that if each individually we are replicating each node already, then ultimately the whole rack would get replicated, right?
No. So not node, we are not replicating node here. You are mistaken. We are replicating only blocks. The data blocks we are replicating, not the nodes. Node we are replicating means what data is present on the node is as is present in the next one. No, only the blocks are, and that to be, these blocks are replicated in such a way, if a node is down, still data is made available. It is not like that no two nodes on the cluster, Hadoop cluster are identical in terms of data. My question is here, if the switch, something goes wrong with the switch, this entire rack becomes unavailable, then in that case also there is a solution here. That is why your Hadoop cluster is being set up with a concept called rack awareness. What do you mean by rack awareness? Out of 3 copies, now I told you, right, if the replication factor is 3, same block is also present in 2 other different places. This is original, one is present in this node and the other one is present on the other node. Are you getting my point, friends? The same block is present on this node and even on this node if the replication factor is set as 3. Are you getting the point? If the replication factor is 3, then the same block is present on other 2 nodes, this one and this one. Now it is been done in such a way, these 2 may be on the same rack and this will be on a different rack. Even if this rack is down, still this block is present on the other rack. That concept is called rack awareness. So at the time of distributing the blocks to my nodes, this rack awareness concept is also been taken into consideration. Even if the rack is down, still the data is being made available.
So basically third replication will be on some other rack, not on the same rack.
Exactly. So rack awareness concept is going to ensure that all 3 replicas, 2 replicas and 1 original, never will be on one rack. 2 will be on one rack and the other will be on the other rack. So even if the rack is down, still my data is being made available. So node is down, anyhow my data is available. No second thought. Even if my rack is down, these are the only two possibilities. Beyond this is a cluster complete unavailability. You got the point, friends?
So, Srinivas, one question. All this rack awareness concept and replica, this information will be in the name node?
Absolutely. This is being completely monitored, managed, taken care by the name node. That is not, we only store the data by giving the command, at my HDFS level. How that kind of command can be given at the terminal, which is connected to my Hadoop cluster. I say Hadoop FS hyphen copy from local, and you take abc.txt /tmp/sandbox /my data. I copy there, that's it. I just copy my files. Usually I don't copy like this. The data is going to be ingested into my cluster automatically with the tools like, you have the tools. What tools we have? Like Flume, Kafka, Nifi. All these are the various tools with which we ingest the data into HDFS by reading it from different sources. We will not be doing that manually. If needs to be done manually, you just know, you can understand. It is definitely not possible at the big data level. So this is an automated process, but to make you to understand at this stage, I'm showing you this command where you can copy the data from your local file system to HDFS. Then what happens? Now making this rack aware and making the replicas all and distributing those replicas to different nodes, all the responsibility of your name node. So that is not our headache. That is what the beauty part, and that is the reason why we call this as a highest level of abstraction. All these complex details are being hidden inside. The highest level of abstraction when you come to your name node. All the complex details are being hidden inside. All the complex details are being hidden inside. And we need not worry for that. And it is being taken care implicitly. As a programmer or as a developer, even as an admin, we need not worry. That is all the headache of your name node. You only need to instruct your name node with certain commands. That's it. Rest of all, the actual activity is being taken care by the respective daemons. Able to get the point, friends? And this point is also been given as part of this. You want, I can show you, friends. To minimize global bandwidth consumption, tries to satisfy a read request from the replica that is closest to the reader. So replica selection this is. Okay. Replica placement. How the replicas are being placed. You see here, the name node determines the rack ID each data node belongs to via the process outlined in Hadoop rack awareness. You see what this Hadoop rack awareness is. Hadoop components are rack aware. What do you mean by Hadoop components are rack aware? All the components that you deploy on the Hadoop cluster, they're all aware that when I am trying to store the data or trying to process the things, it is all been rack aware. I mean, even in the odd situation, if the entire rack is down, still the processing should not be affected. Like that it is been. For example, HDFS block placement use rack awareness for fault tolerance by placing one block of replica on the different rack. This provides data availability even in the event of network switch failure or partition within the cluster. See, friends, which I've already covered as part of my discussion. But to get more information with examples, with other stuff, that is possible only when you read the documentation. Now, at least you agree with me now, friends, what we mean by data replication and what we mean by file system namespace and how data is being stored, what is name node, what is data node, job tracker, task tracker, all these things, if you can go through this document, you'll be able to understand very easily, which has already been covered. But to get the actual theoretical stuff and take some important points and use them as part of the interview process to make you to be successful. And every line that is present in the document, it is definitely tough to cover. That is the reason why I'm giving you the access to this one so that you can read at your comfort and improve your skill set by adding more theoretical information to your existing knowledge which you derive from the sessions. You go through this entire document, you will not find even one concept which is not covered in the class. You will find all things, but at a different level, you'll be able to see the information here. Right? It makes sense, friends?
Yes.
So for the next few sessions, at least, I want more response from your end so that I understand how this style of delivery is suitable and easy, understandable to you. I come to that conclusion. Then I need not ask you every time you understood or not. So please make sure, friends, if you have, but I appreciate you are coming out with queries then and there itself. I really appreciate. So please continue the same so that our sessions will be more interactive, right? So let me talk about one more aspect now here. That is.
So, Srini, before going further, so name node and secondary node, both will be on the same rack or will be on different racks?
Usually Usually I keep it on a different rack, usually because something goes extremely wrong with this rack and I'll not be able to rectify I mean extreme things, but nothing wrong that if both are on the same this thing, nothing wrong. There is no what I say thumb rule that definitely it should be on a different, but if it is on the same rack, then the sync between a name node and the secondary name node will be bit fast. Otherwise, it takes usual time. But I prefer to keep this one on a different rack so that I'll be more safer. Of course, in the current day Hadoop clusters, secondary name nodes doesn't play a major role. There is a new mechanism here with the advent of Zookeeper. So your name node availability is guaranteed. So we don't need to depend on a secondary name node at all. There's a new mechanism, but still conceptually we need to learn. That is the reason why we are learning. But your Hadoop clusters are now getting upgraded to newer and rich features. Even without a secondary name node, your name node can survive in the worst situations. Its data is being made available. See why name node is required basically? I don't need it as a machine. I need its data, because with that only I come to know where my files are present. You see this diagram, what I am showing you here. If you look at the diagram, see this diagram. What do you understand from this diagram? My name node only knows what is a file called foo, how many blocks it has got, and where those blocks are present. That is why name node only stores metadata, but not the actual data. Actual data is being stored by the data node only. But where that data is present and how the data is meaningful, all those things will be taken care by name node. Is that clear?
Yes, Srini.
Wonderful.
Srini, I have a couple of questions. So which process is taking care of that data node, name node and the secondary node is always in sync? Is there any process which will be running at the backside to sync?
Exactly. So we are going to specify at the time of setting up the cluster itself, we are going to specify on which node we are setting up the name node and which node we are setting up the secondary name node. That is being set up at the time of setting the cluster itself. So name node and the secondary name node are always been in sync with the built-in service. We need not even attach anything, because at the time of setting up, it is been done automatically. But only thing is, only choice to the administrator is on which node we need to set up a name node, on which node we need to set up the secondary name node is in your control. Usually I do that on a high configured machine compared to your other slave nodes. These are bit high configured machines. So in a typical Hadoop cluster, we'll have at least 5 to 7 high configured machines and rest of all the commodity hardware. We did not do that one. That has been implicitly true.
Okay. And thanks.
So to the yeah, Murthy, one second. So I want to add one more point to that. So the what is it? The sync will be an instant sync, or will there be any time lag or something like that?
No, the sync will be instant. The sync will be instant because there will be file system image being maintained by the name node, and every change that you are making now will be in the temporary buffer, and periodically these changes will be committed to FS image. There is something called FS image, called file system image. Your recent changes are going to be committed to the file system image, and this file system image is being backed. See what the changes you made at the very worst scenario, the delta that you have as part of that one, only that we may lose.
Okay.
The delta, I mean, the very small change that you made, which is not committed to the file system. Usually, this committing this one to the FS image is being done very frequently. For some reason, if there is anything left over in that delta, that we will be losing. At the very grassroots level, if you minute level you go and see, the sync will be with the file system image of name node and the file system image of your secondary name node along with the delta. Now delta came when it is about to sync with the delta of even secondary name node also will have a delta. This delta and that delta. When that is getting transmitted, something went wrong. Only that small portion is been lost. Rest of all will be in sync all the times with your secondary name node. You got that sensitive point. I don't know who raised this one. You got that sensitive point?
Yeah, this is Sunil. Yeah, I got that.
Yeah, wonderful. So only
Uh,
that very small delta, but that is the rarest condition, but still, but in the recent clusters, that concept doesn't arise because Zookeeper makes your name node available all the times. So that is why we are not worried. I mean, as of today, we are not worried. But sometime back when the Hadoop cluster is being developed, so that small risk is always there. Any time that small risk is always there. Very small risk.
okay, Srini, a couple of more questions. Sorry. The question number one is the replication factor. Say if my file name is foo and the block is 124, and if I have any update to that data set 124,
Yeah,
how those replication, all the places will get updated?
absolutely. So usually we will not be doing that. Let me put it in this way, and let me also give you the explanation why we do. So
Is there any
Hadoop cluster
mechanism?
is basically Hadoop cluster. If you read the documentation, it's been very clearly written over there. Hadoop is basically write once, read many times, optimized. See, in most cases, we write the data once, same data we repeatedly read in different contexts to get the meaningful insight of the data that you have stored. Once data is written, I don't think we make the changes. I mean, I understand why you are raising that question. If it is a case of your database transactional, now the same value gets changed repeatedly. So that kind of situation will not be there with your Hadoop. But even if that is there, it is being taken care. Yes. That is why every block will have a timestamp being clearly mentioned. The last modified, last accessed timestamps are always there with your Hadoop, in terms of your metadata, Hadoop cluster.
Okay.
Yeah.
Okay, thanks, Rini. And my next question is, you told the name node, once we submit any job, when we push any code, that will be communicated to the name node, and with the help of name node, it will be assigned to the uh, task tracker,
No, no,
sorry,
no.
job tracker,
Yeah.
job tracker,
No,
and
no.
through the job tracker.
Yeah, the code is submitted to the job tracker directly. Job tracker will internally communicate with the name node to fetch
Okay,
the data about, for this data set or file where the data is present on the cluster, it will ask.
okay,
So that is,
and it will,
yeah,
okay, and it will reach to the data node and its task tracker accordingly.
absolutely. Absolutely.
So suppose if the task tracker or data node is failed, task tracker, I don't know whether it's a process. If it is failed, when the job tracker is trying to assign any jobs to the task tracker, what will happen?
No
What
problem.
is the,
The other replicas are there, right? In the other other nodes. So those replicas have been considered for your processing.
Okay, okay.
My choice 1 is always the original. My choice 2 is, if that is not available, the job will not be affected. It will be continued with the
Another task
yes,
tracker.
another task. Exactly.
Okay.
It's clear? Yeah, wonderful, friends. So coming to the next aspect, any more questions?
No.
Okay, wonderful. So coming to the next aspect, which I thought of discussing with you, Hadoop, your Hadoop is available in three different modes. In three different modes. One, standalone mode. Two, pseudo cluster mode. Three, fully distributed mode. Pseudo cluster mode and fully distributed mode. So Hadoop exists in one of these. Let us take the first one. This is the simplest one, which is not being used by us anytime. This is only to quickly test MapReduce jobs. Nothing more than that. Standalone, I mean, I go to my hadoop.apache.org. There, I download the bundle. I set Java home and I set Hadoop home, where I'll be able to run my MapReduce jobs against the data present on my local file system only, not on my HDFS. So this is quickly to test my MapReduce jobs. Its sole purpose is that one only. It doesn't have any other usage. Simplest and the which can be quickly set up, and which is of not used to me as a developer or even in the production environment. But if you want to quickly test a MapReduce job against the data present on local file system, yes, that can be done through your standalone mode. So where you download the zip file, I mean the from the you go here, you have something called download. In the download page, yes, you go to the you can see download the release of Hadoop source and Hadoop yes, you can see that here. Sources can be downloaded. Even you want a specific version, even that can be downloaded. You can go to whatever, right? Or even you can go to the mirror site, and I go here, assume. So I go to the current one, and here source I have, and I have my binary also, which is 245 MB, which I can download and set up. What I get with this is I'll not be able to make the cluster. I'll only be able to get my MapReduce and all the required libraries and all to just make my MapReduce jobs run against the local data present. It's only to quickly experiment with your MapReduce, not more than that. That is the reason why we don't see this or we don't use this one in our sessions. Second is pseudo cluster. No doubt this is the cluster mode. The reason why we are using pseudo is for the reason 5 daemons, what I explained you now, all these will be running on one machine. One machine, but 5 daemons will be running inside. So your name node, secondary name node, job tracker, task tracker, all will be data node, all will be present on the same. And one other, because of everything present on one machine, there will not be no replication will be there. Only this is not possible in your pseudo cluster. Rest of all, what you can achieve with your fully distributed mode, everything you can achieve with your cluster, pseudo cluster mode even. Why there is no replication factor? Because at most we can have only one data node here. How we can do the replication? Replication cannot be done. So you want to do the replication, you require multiple machines. On one machine, replication is never possible. That is the reason why we are going to restrict the replication factor to 1 by default on a pseudo cluster. And in the fully distributed mode, as explained by me, all these 5 daemons will be running on independent machines. Name node here, secondary name node here, and data node and your task tracker here, and somewhere here you have your job tracker. So like this, your services will be running on different nodes on different machines. That is called fully distributed mode. There, replication is also possible. The factor you decide. It could be, default is 3. It could be more than that even. So, as part of our sessions, we are going to help you in setting up pseudo cluster on your boxes so that you can practice all the things what we discussed in the class without any difficulty. And at some point during our discussion, I will show you a fully distributed mode, a complete cluster, which we have set up for our POCs and for building use cases and working on with different assignments from our clients time to time. So we have our own 6-node cluster available. So on that cluster, we usually populate some data, and we try to crunch those things and see. And a lot of use cases we work on, and specifically while doing the POCs to the clients, we take the help of this fully distributed mode. That is the complete cluster what we have. I'll also show you, and then you are going to decide, oh, my pseudo cluster and fully distributed mode doesn't have any difference except the replication. Instead of me talking about that theoretically, I want you to experience your pseudo cluster initially, work with it closely. Then if I take you to the fully distributed mode, you yourself can understand there is no difference except your replication factor when you come to your fully distributed mode. So in the coming days, friends, probably in the next session, I believe, I'm going to help you out in setting up of the environment. But in order to make that possible, I want you to do 3 things. 1, make sure you have a laptop with at least 8 GB and 50 to 100 GB hard drive space and 64-bit machine. Of course, all the latest laptops are by default 64. Only thing you need to bother about is RAM, 8 GB RAM, 8 GB RAM or more. 2, download CDH bundle. CDH is nothing but Cloudera distribution for Hadoop. That is called CDH, Cloudera distribution for Hadoop. The third thing is my VMware player latest. And in order to do these things, let me take you over there. Why I need that one is for the reason it's a AV file which you cannot do it when the class is going on. That is why I want you to do it in advance. Go to cloudera.com. Cloudera, C-L-O-U-D-E-R-A, cloudera.com. Go to the download section. And go to quick starts here, download now. And there you should give VMware. Quick starts for CDH 5.8 VMware. Get it now. It is around about 4.5 GB file which you need to download. 4.5 GB file which you need to download. Right? So download that one. That is one thing. And the next thing is VM player. See here, this is a free one. You need not worry, friends. This is a free one. You can get this one. You can go and get this one, workstation for Windows. You can get that, and that you can set up. Workstation player. You click on workstation player. Yes. VMware Workstation 12.5 player for Windows 64-bit. Click on download, so that you will be able to download VM player, what you are seeing here, VMware Workstation player. You should get like this. Once you download and set up that, you should get this. And this is only for your personal usage. For non-commercial purpose, it can be used, no problem. So I want these two things to happen, so that setting up of the cluster on your box is going to be easier for me. At least on one of your boxes, I'm going to do that, so that you gain the confidence how this can be taken care. Make sense, friends?